Algebra 1, Chapter 2, Section 1. Something I'd encourage you to do is think back to yesterday. Before we start, if we were in person right now, we'd be taking a quiz. And question 1 would be, what's the order of operations for? Why does it exist? So take a second and reflect on that. Pause the video if you want extra time to reflect. The order of operations exists so you have an order to do the problems so that you get one right answer. If we were here, then I'd follow that up with a 7-point question and say, tell me what the order of operations is. So maybe pause the video, reflect on that. What the order of operations is: number 1 is parentheses, number 2 is exponents, number 3 is multiply and divide, number 4 is add and subtract, number 5 is not a number 5. Number 5, or thought 5, I'd prefer to do off by the side and say that on ties you work from left to right, because the tiebreaker can apply to any of those levels. Today we dig into exponents in particular. You probably noticed, maybe noticed, yesterday's homework I don't think had any exponent problems, because the book had not really officially gone through exponents with you. So they did the order of operations basically without any exponent problems appearing. Today, exponent problems appear, so here's a discussion about exponents. If we were in person, out of these notes, we'd be building a quiz to take tomorrow, but again, I'm not going to quiz you when you're at home right now. So some things to know about exponents. This number has a name. This number has actually 2 names. As we talk through these, feel free at any point. It's better for you to think than just listen. In class, I like to pose a lot of questions. That makes you think, give you some think time. On the video, it's sort of weird to ask a question and pause. But you could pause this at any time and try to think of the answers as I suggest this. But these have names. See if you can retrieve those. This number is called the base. This number is called a power or an exponent. What 5 to the 3rd means is that you want to do 5 times 5 times 5. The base appears repeatedly. The power tells you how many of those bases need to appear. So 5 times 5 is 25. 25 times another 5 is 125. If we were taking a quiz in the next day, you'd need to know the names base, exponent, and power. That would have been a couple points, I'm sure, on the next quiz. I'm going to take a step to the side and work through some exponents. And we're going to try to generate some rules, and I'll fill the rules back in over there. But if I want to do 2 to the 3rd, even if you want, pause the video and take a second, see if you can figure out some of these. If you want to just listen along, that's fine too. 2 to the 3rd is 2 times 2 times 2 is 8. 2 to the 2nd means 2 times 2, that's just 4. 2 to the 1st, we're going to have a rule about this in a second. 2 to the 1st is just 2. If you have one of our 2's, that total would just be 2, and that's a rule in a second. 2 to the 0, we can usually get an interesting conversation going in person of different people thinking different things about this. You could, again, the more you pause the video and think and try to fill stuff in and see if you get surprised, I think the more benefit you'll get out of these videos. But 2 to the 0 is going to be 1. Negative powers perform a certain task. I don't believe these appear in the homework, but just to preview negative powers, because that'll be a big part of your Algebra 2 life. There's a pattern to what's going on here as we work through these 2's. That you might be able to take a moment and reflect and figure out what this is without me telling you. This is going to be a half. This one's going to be a 4th. And this one's going to be an 8th. And now that you saw those, maybe you can figure it out. If you did it before, I don't know. But if you can't, here's an explanation. With powers of 2, as you move up the chain, you keep multiplying 2. So if you're trying to move down the chain, you're doing the opposite. You'd be dividing by 2. So if we're going to divide by 2, divide by 2, divide by 2, the only way this makes sense is to land on 1. And if you do 1 divided by 2, it's got to land on a half. And divide that by 2, you'd have a 4th, and so on and so forth. not appearing on a quiz in your world, but someday in Algebra 2, it's worth filing away. Math has a way of coming back to you. What negative powers do is flip things. So 2 to the positive first and 2 to the negative first, it's the same kind of thing, it's just upside down. This is a fraction right now over an invisible 1, just put it upside down. 2 to the negative 2 and 2 to the positive 2, it's the same kind of result, just flipped upside down. Likewise, 2 to the third, 2 to the negative third, same thing, just flipped upside down. So a moment ago, we did 5 to the positive 3 was 125. 5 to the negative 3 is therefore a 1 on top of a 125. Again, I don't think that's in today's homework. It wouldn't, I don't think, make the quiz if we were taking quizzes, but that's just a preview of coming attractions. So some things that we can glean from this, and we'll take a step back over here. We just learned what anything to the 0 is. Give yourself a self-check if you were really focused in the last 5 minutes. You should have picked up that anything to the 0 power is 1. That would be a quiz question if we were in person. You could have picked up from over there anything to a 0 power, or anything to a 1 power, excuse me. Anything to the first power is always itself. We just saw that over there when we did 2 to the first power, it was 2 itself. We didn't talk about 1 going to any power, but if you think about that for a second, I think you could figure out 1 to any power, 1 times 1 times 1 times 1 kind of stuff, is always 1. Likewise, 0 to any power, you could figure out 0 times 0 times 0 times 0, no matter how many zeros you had, would get stuck on 0. We just talked about the first power. Anything to the first power is just itself. And you don't usually have to write the first powers. If you ever see something like x to the first, you could just write x. Instead of writing 2 to the first, you can just write 2. If you ever see things without powers, invisibly they have 1s. But a lot of times in math, we just don't write those 1s. The second power has a special name, and maybe you remember this from your memory banks. Third power has a name. Maybe pause if it's not coming to you right away, see if you can retrieve that information. The second power is always called squared. The third power is always called cubed. So I could read this as 5 cubed. Or over there we had 2 squared, that kind of thing. Another power that's special is when the base is 10. If you do 10 to any power, you're going to get answers that look kind of like that, where the 0 count matches the power. So 1, 2, 3, 4, 5, that would be an answer for 10 to the 5th. It has 5 zeros, so it's 10 to the 5th. If I did a million, 6 zeros, that's 10 to the 6th. But 10 to any power, you're going to end up with a 0 count that's a match for the power. Stepping over here, this is order of operations based. Okay, we learned yesterday that the order of operations, exponents are pretty high. Parentheses are higher, but exponents are pretty high. So if you take on a question like this, there's a negative that wants to attach itself to this number. That's a type of multiplication. There's a 4 that wants to do some exponent work. The exponents are higher on the order of operations list. So if I give you a question like this negative is not important. The exponent is more important to do first because the order of operations says so. This wants to get 4 of these 2's. 2 times 2 times 2 times 2. Work that out to be 16. The exponent will happen first. This negative is just kind of hanging around. That's going to go on later. That's a type of multiplication that's lower on the order. So this question is different because I threw parentheses on it. Okay, the parentheses have made the negative and the 2 be a married unit here. These guys are together. Negative and 2 are stuck. Okay? This 4 being outside the parentheses means it goes with both of those. This is a negative times a negative times a negative times a negative. Every time you get 2 negatives multiplied, that's a positive. So if we have 4 negatives, Two of them make a positive, two more make a positive, everything's positive. This is a positive result. It's still 16 because we're still doing 2 times 2 times 2 times 2 times 2. Okay? But these are different because of the parentheses. This negative means the problem had one negative. This negative, there's actually 4 negatives because the negative that's in there happening with the power, it happens repeatedly. So on a question like this, if I asked you how many times this negative takes effect, that's different than how many times this negative takes effect. You could try to think that through for a minute. This negative is only happening once. There's a single negative happening. This problem wants to do 2 times 2 times 2 first to come out with 8, as we did a second ago. And then this negative just goes on. This negative and the 2 are both as a group going to happen 3 times. So we're thinking negative times negative times negative, 3 negatives, but that still turns out negative. Okay? 2 negatives make a positive, the lonely extra third negative makes it negative, but still 8. Even though the problem looked different, and even though the thought process is different, they can still arrive at the same answer. These didn't get the same answer. It was different problems, different processes, different answers. This, different problems, different processes, but same answer. This is different. Okay, this problem has 2 negatives, each of which only happen once. Okay, if I wanted the negative and the 2 to both happen 3 times, it takes parentheses, which I have, but the power would have to go out of the parentheses. Okay? This doesn't mean the same thing as this. This 3 goes with the 2 and the negative. This 3 being inside the parentheses is different. It only goes with the 2. Okay, so for this problem, I'd go 2 times 2 times 2 is 8. I'd stick on 1 negative, and then I'd stick on another negative, and 2 negatives make a positive. This is basically a minus minus makes plus problem. These minuses go together. The 3 is with the 2. Powers happen first, then that stuff happens. So this, if we were here in person, I'd ask you how many negatives are involved in this problem? 1, 2, 5? What's up with that? And the answer is 5. This negative, because of the power being out and the negative being in, that's going to happen 4 times. The negative and the 2 are together. They both happen 4 times. Then this is just hanging around waiting for later. So if you go negative times negative, times negative times negative, 4 negatives would make a positive, and then this 5th negative would get us back to negative, and we'd get negative 16. This, if you were here, I'd ask you how many negatives are in this problem. If you want to self-check at home, go ahead, take a second. That answer is there's going to be 4 of them. We're going to get the negative and the 2 are married. There's 3 of each. So negative, negative, negative. The 4th negative gets us back to positive. 2 to the 3rd is still continuing to be 8. This is something to do with 16. The question is how many negatives there are. Answer on this is 2. This 4 happens only with the 2. 2 times 2 times 2 times 2 is getting us 4 2's up to 16. These minuses have nothing to do with the power. Power happens first, minuses happen later. This one is a lot like this one. It's unlike this one. It's different when the power's out. That goes with everything that's in. This power I slipped in, so the power just goes with the 2. 2 negatives make a positive 16. These would be 2 quiz type rules if we were here. If I put a negative in parentheses and do an odd power, that's what makes things turn out negative. If I do a negative in there and go even power, that's what turns things out positive. So any question where I just had 5 negatives, that's an odd amount, that was negative. 3 negatives was negative. A single negative would be negative. Any odd amount of negatives goes negative. An even amount, whether there's 2 of them or 4 of them, any even number, that goes positive. And that's some rules. I'll grab the quiz in a second and just see if you absorbed all the info. We'll worry about that another time. Over here, we're just doing out some powers. So we have all the foundational knowledge we need. We're just going to do some problems. So you have your sheet of notes. What you might want to do is hit pause and see if you can do these problems without me. And then listen in and check your answers as I talk my way through them. I'm going to wander this way and grab my paper. That gives you a second to pause me. So 8 squared, 8 to the second means 8 times 8. That's 64. Fractions, 1/3 to the third power means you could write 3 of these side by side if you want to and multiply straight across. 1 times 1 times 1 stays 1. We had a rule about that. 1 to any power stays 1. On the bottom, 3 times 3 is 9 times 3 is 27. This one, we're following the order of operations. 5 plus 2 is 7. Do parentheses first. Exponents are next. 7 to the second. 7 times 7 is 49. Then 49 times 2 should be 98. This one, do the parentheses first. In the parentheses, we have a power and a subtract. So do the power first. Power wins over subtract. 4 to the second is 16. 13 minus 16 is negative 3. It's positive minus positive, but it's not positive because the first one's not bigger. Now there's a negative inside to get squared, so I rely on this rule. The negative inside going to an even will be positive. This negative and the 3 are both happening twice. Negative times negative is positive. 3 times 3 is 9. This I'm throwing on a decimal. So decimal multiplications, you count things. So 0.2 times 0.2, we'd have a decimal count of 2. This counts, we get doubles of them. We need a 2-digit decimal answer. 2 times 2 is 4, but to have a 2-digit answer, I need a 0 there. If I go 0.2 times 0.2 times 0.2, my count is 3. So I'd have to go 0.00. 2 to the third continues to be 8. If I went 0.02 to the third, now I'd have to count 02, 02, 02. Now I have 6 decimal places. So I'd have to go 5 zeros, and then our friend the 8 at the end of that. The last bit of homework that you'll have to do is some stuff with evaluating expressions again. Just put the numbers in and do the math. So exponents need to happen first. So if I go to do b to the second, I'll have to look up 3 for b to the second. 3 times 3 is 9 for that middle zone. For c to the third, I'll look up that the c is 2. 2 times 2 times 2. 2 to the third continues to be 8. I'd have to look up the a. The a is 4. And then we'll multiply left to right. 4 times 9 is 36. 36 times 8 would be 288. Last one, same thing, do the exponents first. So if I do d to the second, d is negative 3. So the negative and the 3 travel together. It's like they're in parentheses. So the negative and the 3 together take d's job. 2 goes everything that has to do with d. So the 2 goes with the negative and the 3. So negative times negative is positive. 3 times 3, that's 9. Just put e in as it is, that's a 5. Then there's a minus. The 3 goes with anything that has to do with f. F has a negative and a 4. So the negative and the 4 happen 3 times. Negative times negative times negative is a negative. 4 times 4 times 4 is 64. And now we've got to subtract. A little minus minus makes plus in a minute. 9 times 5 is 45. Adding stuff up, we get 109. Homework's on page 57. Works from 1 to 24, 26, 28, 44. And then here's what notes would have been a quiz if you were here tomorrow, so you could give yourself a self-test. I'll read it, I'll pause. You could pause me if it's not enough of a pause. But if we had a quiz, maybe we'll have this quiz someday. What is 1 to any power? So if you follow the rules from over there, what is 1 to any power? That was on the board, that is 1. What is 0 to any power? That one's 0. Anything to the first power? is itself. Anything to the 0 power is 1. A negative number to an even power. By negative number to an even power, I mean this. It's positive. How about negative number to an odd power? That would be negative. Then here's a question I didn't explicitly write on the board, but we talked about. If there's a negative sign in front of the number and not in parentheses, what does it do? It changes the sign. If there's a negative sign in front of a number that's going to a power, but it's not in the parentheses, it's going to change the sign, and it's going to do that at the end of the problem. It did make the quiz what negative exponents do. I don't think that makes the homework, but what negative exponents do is flip things upside down. I'll ask, what's another name for the second power? It's squared from the beginning. Another name for the third power? It's cubed from the beginning. I would ask you some names of the pieces of a basic problem like this, and you could tell me that the 8 is called base. The 2 can be called either an exponent or a power. So if you grasped all that, that's great. Try to file that away somewhere where you can keep it and retrieve it someday when we need it. And that's it for 2-2.